Hi everyone, it's Miss Costa here, and in this video we're going to go through the Foundation GCSE Paper 3 for the November 2017 series. Okay, so to start off with, we've got a rounding question. So I'm being asked to round 3,758 to the nearest 1,000. So the thousands column is this one here. This would be the hundreds, this would be the tens, and this would be the units. So I'm deciding essentially whether it is between 3,000 and 4,000. So I know that halfway between 3,000 and 4,000 is 3,500, and 3,758 would be roughly somewhere here. So it's going to round up to 4,000. Now the way that I do it, if I can't visualize the thousands, is I circle the digit that is in the thousands column. So that's 3, and I look next door to the number next to it. So the number next to it is 7, and when I'm rounding, I look next door, and if what is next door is 5 or more, I round my number up. So when I round up, I add 1 to the circled number, and everything else turns to zeros. So that would become 4, because 3 plus 1 is 4, and then I'm rounding it to 4,000. So the best way is to just think to yourself, okay, the thousands around 3,758 are 3,000 and 4,000. I know halfway is 3,500. Is it larger than that? If so, it's going to round up to 4,000. But if not, use the circling method. Next, we're simplifying. So when I'm simplifying an algebraic expression and it's using addition or subtraction, what I can do is actually imagine it's a real thing. So y plus 3y take away 2y. So if I imagined that was a yacht, I've got a yacht, and whenever I'm saying what y, there's an imaginary 1 in front of that. I don't say I have one apple, I just say I have an apple. So whenever I have just one letter by itself, there's an invisible 1. So I've got 1y plus 3y. So that's the same as saying I've got one yacht, and I add 2 yachts to my little yacht collection. So I've got 4y in total. So I've got 1 plus 3 is 4. But then I'm going to take away 2y. So I've got 1 yacht plus 3 yachts, and then I take away 2 yachts. So 4y take away 2y is the same as saying 4 take away 2, which is 2y. So you can treat this as you would normal numbers. So the algebra is almost like secondary. Just think to yourself, what would 1 plus 3 give you? 4, and then 4 take away 2 gives you 2. So you've got 2 lots of y. And so that's how I do that question. Now I'm writing down all the factors of 18. So a factor is a number that multiplies into your number. So they usually come in factor pairs, and that's the best way of doing it. So the best way is to just think to yourself, I'm going to start off with 1, because 1 is a factor of every number. And I think to yourself, what 1 times what makes 18? 1 times 18 gives me 18. Then I'm going to try 2. 2 times what gives me 18? 2 times 9. And you have actually the calculator with you, so you could literally just try dividing every number by 18. So I tried 2. 18 divided by 2 is 9. 2 times 9 makes 18. Then I'm going to try 3. So 3 times by 6 gives me 18. If you didn't know that and your times tables aren't that good, you just literally type in 18 divided by 3. It's a whole number, so you know it's a factor. Then we can try 4. 4 doesn't go into 18. If you type it into your calculator, you do 18 divided by 4, and you realise that it gives you a decimal. For a number to be a factor, it needs to multiply into it like a whole number. So 4 needs to multiply by a whole number to give you 18. You can't do that because 4 times 4.5 gives you 18, therefore it's not a factor. Then we try 5, but 5 doesn't go into 18. Then we try 6. And well, 6 times 4 gives you 18, but what you might realise is that you've got 6 on this side. So as soon as you've got a number on this side that's the same as on the right side, you know you've reached all of the factors. So you don't need to keep on trying, because if you did, you try 7, then 8, then you get to 9, and you know that 9 times 2, but you've already mentioned the 9 over here. So you start by writing your factor pairs and then you list them. So you go down, so you'd say 1, 2, 3, and then up 6, 9, 18. These are the factors of 18, and the reason you do that is just because you are listing them in ascending order, which means from the smallest to the largest. Okay, next we've got a money problem. So we're told that the table gives information about the prices of cinema tickets. Adult ticket is £7.80, child ticket is £5.80, and a family ticket for 4 people is £24.30. So Mr. Edwards and his 3 children go to the cinema, and you need to decide whether it's cheaper for Mr. Edwards to buy 1 family ticket rather than 4 separate tickets. So, oh no, you don't need to decide, you are told it is cheaper, and you need to figure out how much cheaper. So I know that a family ticket is going to be £24.30, and then individual, what am I going to have to do? So it's Mr. Edwards, who is an adult. So I'm going to have 1 adult ticket plus his 3 children. So 3 lots of child tickets. So what's the cost of an adult ticket? It's £7.80. And the cost of a child ticket is £5.80. So I could work out what that would cost. So £7.80 plus 3 times by £5.80, which gives me £17.40. So I've worked out that 3 child tickets cost £17.40 because there's 3 children. I then add this together. So £17.40 plus £7.80 is going to give me a total of £25.20. So to get separate tickets, it's £25.20, and to get a family ticket, it's £24.30. I need to work out how much cheaper it is, so I'm going to do £25.20 take away £24.30, and that's going to tell me the difference. To work out the difference between 2 prices, I just subtract. So take away £24.30 gives me 0.9, which is 90 pence. So how much cheaper? Either you say 90 pence cheaper, or you say £0.90. Okay. The film starts at 6:45 p.m. and the film lasts 102 minutes. What time does the film finish? So this is where we want to convert minutes to hours, and in 1 hour I have 60 minutes. So let's think about 102 minutes. What is that going to be in terms of hours? Well, 60 minutes is 1 hour. And then 102 take away 60 is 42. So I've got 1 whole hour in there plus 42 minutes. So it'll be 1 hour, 42 minutes. It starts at 6:45 p.m. So if I add on 1 hour, that takes me to 7:45 p.m. And then what I need to do is add on 42 minutes. Now there's 60 minutes in an hour, so I have to do this carefully, bit by bit. So from 7:45, let's try it over here, from 7 to 45, I need to add on 42 minutes, but I'm going to do it bit by bit because it gets a little bit tricky. So if I add on 15 minutes, that takes me to 8 p.m. So from 7:45, I had to add on 42 minutes. I've added on 15 minutes. So if I do 42 take away 15, that leaves me with 27 minutes left. So then I know I have to add on 27 minutes because 15 plus 27 makes 42 in total. So that would take me to 8:27 p.m. The other way yeah, I mean, time is a little bit of a tricky one just because minutes are in 60 and we're used to working with the 100 system. So just remember that. And I would try break your time down into chunks. So 42 minutes. You could have also actually broken it down into 30 minutes and 12 minutes. That might be a simpler way to do it actually. So 745 would have taken you plus 30 to 8:15, and then you add on 12, so that would take you to 8:27 p.m. But yeah, that's what we do. Okay, so next we have a division problem. So Tyus has a large bottle of shampoo. There are 2 litres of shampoo in the large bottle. Tyus also has some small empty bottles, and each small bottle can be completely filled with 150 millilitres of shampoo. How many small bottles can be completely filled with a shampoo from the large bottle? So 1 litre, using my metric conversions, is 1000 millilitres, and this is just a fact that you have to memorise. So if 1 litre is 1000 millilitres, I can figure out how much 2 litres are going to be, because to get from litres to millilitres, how do you get from 1 to 1000? You times by 1000. So what I'm going to have to do is times 2 by 1000, and that would tell me that 2 litres is 2000 millilitres. So I need to figure out how many lots of 150 millilitres fit into 2000 millilitres, and to figure out how many lots of something fits into something, we use division. So we're going to do 2000 divided by 150. So that tells me how many lots of 150 fit into it, and 2000 divided by 150 gives me 40 over 3, which is 13.3 recurring. So that means that 13 full bottles can get filled, and a third. So we can't count a third of a bottle because we want to know how many small bottles can be completely filled. So therefore we'd say 13 bottles for that one. Okay, and now we've got a pictogram question. Now a pictogram is just where you are trying to show a number using a picture. So in this incomplete pictogram, it shows the information about the number of cycles sold in a shop on Tuesday, Wednesday, and on Thursday. We are told that a total of 20 cycles were sold on Tuesday, Wednesday, and Thursday. So in total, all 3 of these pictures, so that's 1, 2, 3, 4 full wheels plus 2 half wheels makes 5 full wheels. So we know that 5 wheels must equal 20 bikes. So each wheel, if we divide 20 by 5, it tells us that 1 wheel must represent 4 bikes, because a pictogram, the picture represents a certain number of the thing you're doing. So in this case, we figured out that 1 wheel must represent 4 bikes because 5 full wheels make up 20 bikes. So then we've got a blank key. We can just write over here that 1 wheel is equal to 4 bikes. And now we're told that 8 cycles were sold on Friday. So I'm going to just need to do 1 full wheel, which makes 4, and 2 full wheels makes 8. And 15 cycles were sold on Saturday. So how do I make 15? You've got 4 plus 4, that's 8, plus 4 is 12. And so you want to make 15, which is 3 more than 12. So let's think about this one. So we're just going to do it in terms of circles. If a full circle gives you 4, you know that half a circle would give you 2, and half that again, so a quarter circle, would give you 1. So to create 3, you're going to need to add on a quarter circle over here. So it's basically going to look like a 3/4 circle. So to make 15 cycles, we've got 1 cycle, so that's 4, 8, 12, and then my 3/4 of a circle. And we can just shade it in like that. Okay, Next, we've got some angle reasoning. So I'm told that BCD is a straight line, ABC is a triangle, and I need to show that triangle ABC is an isosceles triangle. Now, the key thing that you need to know about an isosceles triangle is that it has two equal sides and two equal base angles. Now, they don't always have to be on the bottom. There's a common misconception that the angles have to be at the bottom, but if you flip that triangle around like that, this is where the angles would be. Or if you flipped it on its side like that, this is where the base angles would be. But you've got two equal sides, and beneath them, there's two equal angles. So step one, what we're going to want to do is figure out what the missing angles are. So here I've got a straight line, and I know that angles on a straight line sum to 180 degrees. This is an angle fact. Because it says give a reason for each stage of your working, you're going to have to write the full fact out. So angles on a straight line sum to 180. So we do 180 take away 170. 180 take away 117, which would give you 63 degrees. Again, it's a calculator paper, so you can use a calculator for that. Then we know the other angle fact that we should know is that angles in a triangle also sum to 180 degrees. So that must mean that 180 take away this angle, 54, take away this angle, 63, is going to give me my missing angle over here. So into your calculator, you can type 180, take away 54, take away 63, which gives you 63 degrees. So to show that it's an isosceles triangle, you say the triangle has two equal angles, therefore it is isosceles. Okay, so in this question, I'm shown a bus next to a building, and the bus has a length of 12 meters in real life. So what I want to do is measure the actual length of it on the drawing. So that would be 2 centimeters. So I know that 2 centimeters is 12 meters in real life. That then means that 1 centimeter must be 6 meters, as I've divided by 2. So what I can do is measure the length of this building, which is 5 centimeters. And if 1 centimetre is 6 metres in real life, then 5 centimetres I'm going to times by 5, and that is going to get me to 30 metres in real life. Now, there's quite a lot of ways that you could have done this, and depending on your measurements on your ruler, anything between 27 to 33 metres would be absolutely fine. Next, I've got a prime number question. So NIDA writes down 2 different prime numbers, and remember, the prime numbers are numbers that only have 2 factors, 1 and itself. So the first few prime numbers are 2, 3, 5, 7, 11, and these are things that you should kind of memorize and know off by heart. So she adds together her 2 numbers, and her answer is a square number less than 30. So what I can do is think about the square numbers that are less than 30. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, because remember, a square number is a number times by itself. That's literally the definition of a square number. So 4 times 4 then is 16, 5 times 5 is 25, 6 times 6 is 36. So the only square numbers under 30 are 1, 4, 9, 16 and 25. So let's think about the prime numbers that could be that could add to this. So we've got 2, 3, 5, 7, 11 are my first prime numbers. Then I've got 13. 15 is not a square number because it's divisible by 5. 17, 19, and then 23. If you're not sure about your prime numbers, you could list all of the numbers. Basically anything that is a multiple of 2 apart from 2 is not a prime number. that sign just means not equal to a prime number. Anything that is a multiple of 3, obviously 3 would be an extra factor, so it's not a prime number. And anything that's a multiple of 5 is not a prime number. So these would be the options that I have. So out of these, 2 plus 23 gives me 25, which is a square number. I could have also done 11 plus 5, because that gives me 16. I could have also done 7 plus 2, because that gives me 9. And are there any others? There might be some others, but basically any of these numbers added together to give you one of these numbers, which are the square numbers. So knowing your square numbers and knowing your prime numbers is quite important. So they're just numbers that you can either memorize, or for your square numbers, you just literally try multiplying each number by itself. So 1 times 1, 2 times 2, 3 times 3, and so on. Next, I've got a fractions question. So Jim thinks of a number and 2/3 of his number is 48. So I can just visually draw this just to help make sense of it. So 2/3 means something has been split into 3 parts, and 2 of those parts are equal to 48. So 2/3 is equal to 48. Therefore, I could work out what 1/3 is by dividing by 2. So 48 divided by 2 is 24. So I know that each third must be equal to 24. Therefore, to work out what the full number is, I can do 24 times by 3. I can use my calculator. So 24 times by 3 is 72. So Jim's original number is 72. And now I need to work out 5/6 of it. So I can do it the quick fraction way if you know it, or I can just visualize it. So 5/6 means something is split into 6 parts. So 1, 2, 3, 4, 5, 6. That's very uneven. The whole number is equal to 72. Actually, that's going to bug me. So let's make it a little bit more even. So split into 6 parts. 1, 2, 3, 4, 5, 6. Still not super even, but you get the point. So first things first, I do 72 divided by 6 to figure out what one part is, and 72 divided by 6 is 12. So I know that each of my parts are worth 12. And then to figure out what 5/6 of it is, I'm just going to do 5 times 12. And 5 times 12 gives me 60. So therefore 5/6 of Jim's number is going to be 60. The quick way, if you're trying to work out fractions, so 2/3 of 48, you could even type it into your calculator, because this is a calculator paper. So you type your fraction button, you write 2/3. Of means times, so you press times 48 and it automatically works it out for you. Oh, did I do something wrong? Oh no, never mind. I'm just showing you how to work out if it was 2/3 of 48. Okay, so next we've got don't know why it says maps and bearings. This is best offer question. So Jack's driving school has 2 offers. Offer 1 is first driving lesson free, all other driving lessons normal price. Offer 2 is all driving lessons are 5% off the normal price. So the normal price of a driving lesson is £24. Douglas is going to have 12 driving lessons. Which is the cheaper offer? So for offer 1, you get your first driving lesson free, all other driving lessons normal price. So that means that he pays for 11 lessons. So 11 times by 24 gives me 11 times by 24 gives me £264. So if I go with offer 1, he'd have to pay £264. For offer 2, he gets 5% off the normal price. So if the normal price is £24, 5% off of that, and there's a lot of ways we can do it if you know your multiplier method. So we've got 100% is my normal price, and I'm taking 5% off that, so that means that's 95% of the original price. 95% means 95 over 100, which if I divide it is 0.95. So the quickest way is to do 24 times by 0.95. Or you could also work out what 5% is by working out that 10% is £2.40 and therefore 5% is £1.20 and take it off the price. But let's use the multiplier method. So 24 times by 0.95 gives me £22.80. So that's going to mean that all of his lessons are £22.80 and he's going to have 12 of them. So I'm going to do 12 times by £22.80, which gives me £273.60. So what is the cheaper offer? Offer 2 is cheaper. And you must show how you got your answer, and that's all of the working out that you've done. Next, I have got a direct proportion question. So I'm told that 2.5 kilograms of apples cost £3.60. So what I might want to do is work out what 1 kilogram is. So how do I get from 2.5 to 1? Well, I divide by 2.5. So I'm going to have to do the same to this side. So I divide by 2.5. £3.60 divided by 2.5 is £1.44. So that means for 1 kilogram, he'd pay £1.44. I want to work out what 3.5 kilograms are. And how do I get from 1 to 3.5? I times by 3.5. So I'm going to do the same to this side to keep it in direct proportion. And £1.44 times by 3.5 gives me £5.04. So that's the cost of 3.5 kilograms. Now I have to do a table of values. So I need to complete the table of values for y equals a half x minus 1. The best way to do these is to start from this side because they're the positive numbers. They just make your life easier. So y equals a half x. Well, a half is the same as 0.5. You times that by x and then you take 1. So over here, x is 3. So I'm going to do y equals 0.5 times by 3 and then I'm going to take 1. So that would give me 1.5 take away 1 and 1.5 take away 1 is 0.5. So over here I've got the value of 0.5. They've already done the value of 2, so when x is 2, then I'm going to do the value for 1. So y is 0.5 half of x, so half of 1, and then I take away 1. So half of 1 is 0.5, and 0.5 take away 1 is minus 0.5. You've got your calculator that you can use as well. Then I'm going to try it for 0. Now, once you've done a few, you might notice a pattern, but let's just try keep going on anyway. So y is 0.5 times by 0, and then I take 1. So 0 times by anything is 0, and 0 take 1 is minus 1. And the last one, you've got negative 1. You might have noticed a pattern, and that's the good thing about doing these, is that they're always going to show you a little pattern. So you can see that it's going down in 0.5s. So I can predict that it's going to be 1.5. But let's show if that's true. So I've got y is 0.5 times by negative 1, take away 1. So 0.5 times by negative 1 is minus 0.5. And minus 0.5 minus 1 is minus 1.5. So to complete a table of values, think about what the algebra is doing. So you could have left it as a half times by x, take away 1 if you wanted to, whichever works best for you. And then you use these numbers, these are your x values, you substitute them into the equation over here, and then you can figure out what your y value is. So over here, I'm being asked to draw this, and let's just fill it in. So it was, what was it? 0.50 minus 0.5 minus 1 minus 1.5. And I want to plot that from negative 2 to 3. So I always go along the corridor and up the stairs. So along the corridor to negative 2 and then down to -2. So I put an X over here. Always mark your coordinates with an X. Then you've got -1, and then you go down to -1.5. Then you've got 0, you go down to -1. Then you've got 1, you go down to 0.5. Then you've got 2 and 0, and 3 and 0.5. Now, this is a straight line graph. I don't know why it says quadratic graphs. I think I was very tired when making this. So it's a straight line graph, and you have to, I don't know why that point just disappeared. You have to join your points together with a straight line and a ruler, and then you've got your straight line graph. Now, use a graph to find the value of x when y is 0.3. So when y is 0.3, this is the y-axis. So we're going to go up, and that's 0.1, 0.2, 0.3. We're going to go along that line until we reach the x coordinate, and then we read downwards. Now mine might be a little bit different because I'm not using the pencil and stuff, but that would be 2.5 is halfway, so 2.6, 2.7. So x is 2.7. Okay, so in this question you asked to describe fully the single transformation that maps shape A onto shape B. Now, if it's a single transformation, it means only one thing can happen. And the amount of people that end up writing two things, you get no marks. So it's a single transformation. You can see that the shape must have been reflected because it's looking opposite to what it did before. So what you want to do when you're looking at a reflection is find where the midway point is. That's called the line of reflection. So in this case, we can look at it, and where's the halfway point? Over here, this point here and this point here have a distance of 1 square. Over here, this point here and this point here have a distance of 2 square. So that is my halfway point. Now this is the x-axis, so I'd say it's a reflection in the x-axis. That's all you need to do. If you want to, you could say that it's technically, if I look at my y coordinates, this is when y equals 0. So the x-axis is when y equals 0. So you could say it's a reflection in the line y equals 0, or you'd say a reflection in the x-axis. Over here, we've got the ratio of the cost of 1 metre of cotton fabric to the cost of 1 metre of silk is 2 to 5. So I need to complete the table of costs. So cotton fabric to silk fabric is 2 to 5. So cotton to silk is 2 to 5. And if the cotton is £6, then what have I done? I have times this by 3. So I'm going to have to do the same over here. So that's going to be £15. Now, if this is quite a tricky one, it's involving a lot of things. So I know that 2 meters of cotton is £6. So 6 meters, what have I done to get to 6? I've times it by 3. So 6 meters, I'm going to have to times by 3 as well. That's going to be £18. I can do the same. 2 meters is £6. So 8 meters, what do? I'm going to have to times by 4. So 6 times 4 is £24. And then for 9 meters, what I could do is figure out how much 1 meter is. So 2 meters of cotton is £6. 1 meter is therefore £3 because I divide by 2. And 9 meters, I'm going to times by 9. So 3 times by 9 is 27. So that would be £27. So you've worked out your cotton fabric. The best way might actually have been to just start off by working out 1 meter and then timesing it by 6, timesing it by 8, timesing it by 9. Similarly, over here now, we know that 2 meters of silk is £15. So I could work out what 1 metre is. 1 metre, I would half this, divide it by 2. 15 divided by 2 would be £7.50. So I can just do £7.50 times by 6 to work out what it would be for that. So 6 times £7.50 is 45. And then I could do 8 times £7.50, which would give me 60. And then 9 times £7.50, which would give me £67.50. So the trick here is you're going to use the information that they've given you about the ratio to be able to work out the cost of silk. And then actually the best way would have been to just work out the cost of 1 metre for each of them and times it by 6, then 8, then 9. Okay, so in this question, I am told that Chloe has a van and she's going to use the van to deliver boxes that are cuboids 40 by 30 by 35 centimetres. The space for boxes in the van has maximum length 2.4 metres, width 1.5 and height 1.4, and that the space for boxes is empty and she wants to put as many boxes as possible into the van. So let's first have a think about what's going on. The van is a space, just an empty cuboid. So I could start by working out the volume of the van. So I've got 2.4 times by 1.5 times by 1.4, because the way you work out volume is you can work out the area of the front face first. So let's say that's length is 2.4, width is 1.5 and height is 1.4. So you just work out 1.4 times 2.4 and then you times it by 5. So basically to work out volume, you multiply all 3 dimensions by each other. So 2.4 times by 1.5 times by 1.4 gives me 5.04 meters squared. So the area of the volume of the van is 5.04 meters squared. Then I can work out, so I know I want to see how many boxes could fit into it. So if the length is 40 centimeters, which is 0.4 meters, I could figure out, try to see how many would fit into the van that way. So 2.4 divided by 0.4 is 6. So I know I could fit 6 boxes, lengthwise. And then widthwise, that's 0.3. So I've got 1.5 divided by 0.3 is 5 boxes this way. And how many could I fit going up? So it basically means I've got like 6 boxes by 5 boxes. And then how many fit going up? I can do 1.4 divided by 0.35, which is 4. So that would give me 4 times 6 times 5, which is 120. But I think most people won't think that way. So let's just do it the way that most people would do it. So I know that the volume of the total van is 5.04 meters squared. The volume of the little cuboids, so let's turn everything to meters. Remember to turn 1 meter is 100 centimeters. So we just divide by 100 to turn them into meters. You've got a calculator so it can do the work for you. So the small little cuboids would be 0.4 times by 0.3 times 0.35. And if I type that into my calculator, 0.4 times 0.3 times by 0.35 gives me 0.042 meters squared. So each little cuboid is going to fit, is going to take up a space of 0.042 meters squared. I have a space of 5.04 meters squared. So to see how many little boxes can fit into my big van, I would do 5.04 divided by 0.042. And 5.04 divided by 0.042 gives me 120 boxes. So it's a different way of getting to the same thing. The only thing is, it's very lucky that this question, that the van has the exact space to fit all of these boxes, but I guess it was designed for that size of boxes. So she can fit 120 boxes into the van, and it says she can put 3 boxes into the van in 1 minute. Assume that the space for boxes is in the shape of a cuboid. Work out how many minutes it should take Chloe to put as many boxes as possible into the van. So it's very important that they have this thing, assume that the space is in the shape of the cuboid, because that means it's easy for us to fit all of our boxes in. Work out how many minutes it should take Chloe to put as many boxes as possible. So I know she can fit a max of 120 boxes, and I know per minute she can fit 3 boxes in. So I do 120 divided by 3, which is 40. So it would take her 40 minutes to fit all of the boxes into the van. The space for boxes might not be in the shape of a cuboid. Explain how this could affect the time it would take for Chloe to put the boxes. So if it was in the shape of, I don't know, some kind of weird thing like this, it would take more time, as the arrangement wouldn't be simple. So her van is like, she can just pile them in because it's a nice shape of a cuboid. But if it was sort of a space that goes in and then up like that, she'd have to work hard to find the space. Or if it was in a really weird shape that was like, I don't know, for some reason like this, it would take less time, as she wouldn't be able to fit all the boxes in. So it's just about, when you have a reasoning question, it's about thinking how you could apply this to real life. And if you literally just imagine yourself putting boxes into a van, what could the problems be? Well, the boxes might not fit exactly, like this question was very lucky that the width fit exactly into the width of the van, but if it didn't, then you'd need to rearrange the boxes somehow to fit them in. Okay, next we've got a factorise question, and factorise means take out the highest common factor and put the rest in brackets. So I've got 4m plus 12. Now I want to find the highest common factor of these two terms, the largest number or piece of algebra that goes into them. 4m means 4 times m, and 12, if I know that 4 is the number here, can 4 multiplied by something make 12? Yep, 4 times 3 makes 12. So I know that 4 is the largest factor. I put that outside the brackets, and then I think to myself, 4 times by what gives me 4m? 4 times m, as it says here, and then 4 times what gives me 12? 4 times 3. So that's what I do to factorise. I squeeze as much as I can out of the expression, and I put that on the outside of the bracket. Now to double check if you've done it right, you could just expand it back out. So that would become 4m plus 12, so you know you've done it right. But this is your answer. Okay, so here I need to choose 2 words from the box to make this statement correct. Okay, so 5y is a term, because a term is anything that is like either a number or a piece of algebra or a letter and a number together. So 5y is a term in the, and now this is 2 terms, and when you have 2 terms, even 1 term actually, it's an expression. So 5y is a term in the expression. If it was 3x plus 5y equals 7, that would be an equation. If it had an equal sign, it would be an equation. So factor, nope. Factor is anything that goes, oh, no. Multiple, no. Identity would be when it had this sign. So just knowledge of your algebraic terms. But yes, 5y would be a term, 6xy squared would be a term. Anything that you can put a plus or a minus in between, that would be a term. And an expression is a collection of terms with no equal sign. Next, we've got a sequence from a pattern. So here is a sequence of patterns made with counters. Find an expression in terms of n for the number of counters in pattern n. Essentially what this is asking you to do is find the nth term. So find the rule for the sequence. So let's count what the numbers are. So we've got 1, 2, 3, 4 in pattern number 1. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so what I want to do when I've got expressions is I want to see what it's going up in. So my sequence is going up in 3s each time. So that means it's going up in the 3 times tables. So I'm going to write 3n. But if it was the 3 times tables, it would be 3, 6, 9. So what's the difference between 3 times tables and this sequence? I'm adding 1 each time. So it would be 3n plus 1. Bio has 90 counters. Can he make a pattern in this sequence using all of his 90 counters? Okay, so I know that the rule for the sequence is 3n plus 1. So if he can use all 90 counters, basically, it's going to equal the rule of the sequence. So I'd say 3n plus 1 equals 90. I'd then solve this equation. So I take 1 from each side. So 3n equals 89. And then I'd have to divide by 3. But 89 divided by 3, it doesn't divide exactly. I'd end up with 29.66. So it means that the 29.66th pattern in the sequence would have 90 counters. You can only have whole numbers, like you can't have someone coming 29.66 in a race. They either come first, second, third, fourth. So n has to be a whole number. So no, n is not a whole number. Okay, now we have to work out the mean from a grouped frequency table. So this is where we're going to have to do a little bit of extra work. We're going to have to create an extra column for ourselves and do some work. So whenever you have to work out mean from a frequency table, always just think to yourself, you're going to have to extend the table. Now, this is a grouped frequency table, which means there's an interval. So it means, for instance, this table shows the information about the heights of 80 children. So what does this mean? It means that in the first column, the height is greater than 130 or less than or equal to 140. And 4 people have this height. So what I do is I find the midpoint first, and then in this column, I do the midpoint times by the frequency. So that will make a bit more sense once we do a few. So the midpoint, to find the midpoint, you add the values and then divide by 2, or you can just see it. So halfway between 130 and 140 is 135. Midpoint just means halfway. So I'm going to do 135 times by 4, the midpoint times by the frequency. 135 times by 4 gives me 540. Then I need to find the midpoint here. That'll be 145, and I times that by 11. So 145 times by 11 gives me 1,595. Then I find the midpoint here, 155, and I times that by 24, which gives me 3,720. I do the same here. I find the midpoint, 165, I times it by 22, that gives me 3,630. For the last one, the midpoint is 175, so I do 175 times by 19, which is 3,325. Oh, I've just done, I didn't even read the question. Okay, well, here's how you work out the mean. So we will do the median, but how do you work out the mean? You find the total of the midpoint times by the frequency column. So you add all of this together. So 540 plus 1,595 plus 3,720 plus 3,630 plus 3,325 gives you 12,810. And the total of the frequency you already know, as it's told you. So you do 12,810 divided by 80. To work out the mean, you do the midpoint times frequency total divided by your total frequency. So that's the formula. So you get some extra work to do for working out the mean, and that would just give you divided by 80. So 12,810 divided by 80 is 160.125. But this question isn't actually asking you for the mean, but you just got some free extra practice. So what the question is actually asking for, if I'd read it, is find the class interval that contains the median. So the median is the middle term, and to find the median out of frequency, there's like a rule that you need to use. So you do the frequency plus 1 divided by 2. So in this case, that would be 81 divided by 2. And 81 divided by 2 is 40.5. So essentially, the 40.5th value is going to be where the median is. So what we do is we find out where the 40.5th value is. So the first 4 are over here. So it's not going to be in this class interval. 4 plus 11 is 15. So the first, up to the first 15 terms are here. 15 plus 24 is 35. So it's not going to be in this one. 35 plus 22 is 61. So between these, this class interval here contains all the terms that are between 35 and 61. So it would be this class interval here. 160 is less than or equal to the height, which is less than 170. The median is a bit of a tricky one. Usually if you just halve it and you figure out, because the median is the halfway point, so even the 40th term, you'd be fine. Okay, so now we need to draw a frequency polygon for the information. So the frequency polygon, we always plot it against the midpoint. So that was where the midpoint would have been helpful. So over here, we're going to do the first one. It's 135 and 4. And first I want to check my scales. So this is 0 to 10 and there's 10 boxes. So I know that one box is worth 4. So I'm going to plot it at 135 and 1, 2, 3, 4. Then I've got 145 and 11. Then the midpoint is 155 and 24. And then I've got 165 and 22. And then finally 175 and 19. So when you're doing a frequency polygon, you do join the lines together. And just the ones like that are shown. Some people for some reason join it together like that. You don't do that. You just start from the first point and you join all of your points together. Okay, so here's an exchange rate question, and in these questions it's important to kind of decide what your end goal is. So I'm told that in London 1 litre of petrol costs 108.9p. So in London I know that 1 litre is 108.9 pence. I want to be able to get the same comparison for the US. So I want to find out in the US 1 litre is equal to how many pence. That's my end goal. I could also have done in the US 1 gallon is $2.83 and therefore worked out what London pricing for that would be, but I'm going to just go with London's pricing because I'm in London. Okay, so where can we start? So first of all, I know that 1 US gallon, so 1 gallon costs $2.83. And I know that 1 gallon is equal to 3.875 litres. So therefore, I know that 3.785 litres costs $2.83. Now what I could do is try and figure out what 1 litre is. So to get from 3.785 to 1, what do? I'd have to divide by 3.785. So I'd need to do the same on this side too. So $2.83, 2.83 divided by 3.785 gives me 0.7476882431 cents. So I know that £1 is equal to $1.46. I have 74 cents. I'm not going to write all of it out, it's saved on your calculator. So how do I get from dollars to pounds? I need to divide by 1.46. So to get from dollars to pounds here, I'm going to divide by 1.46. Again, the real good thing is when you're doing conversions, list the facts that you know. So you know £1 is $1.46, and use that, use the arrow to just think, okay, how to get from 1.46 to 1? I divide by 1.46. You're always going to divide by that thing to get to the 1 unit. So 0.747 divided by 1.46 is 0.512. That's quite cheap. So that's 0.5121152. So 1 litre costs, and that's in terms of pounds. So to turn it into pence, I'm going to times it by 100. So that would be 51.21 pence. Wow, that's quite the difference, half the price. So it's better value in London, in New York, as the price per litre is 51.21 pence versus 108.9 pence, almost half price. Okay, so here we've got a density question. So I'm told that a gold bar has a mass of 12.5 kilograms and that the density of the gold is 19.3 grams per centimetre cubed. Now it's really important to pay attention to the units we've been given. So the mass has been given in kilograms and the density has been given in grams per centimetre cubed. So we're going to want to look at that. And I need to work out the volume of the gold bar. So first of all, there's an equation that you should know. The equation for density is mass over volume. If you don't know that, then scribble that down and try and memorize it. You might also know it in the rectangle where density is mass over volume. And we can look at that formula and rearrange it to figure out what we need to do for volume. So when I'm rearranging formulas, so I've got density as mass over volume, and the subject that I want is the denominator of the fraction, I can just switch them round. So volume would be mass over density, just like the triangle would tell me. If I circled that I want volume, I know I need to do mass divided by density. So I've got my formula, volume equals mass over density. Now, because the density is given in grams per centimetre cubed, I'm going to want to make sure that my mass is also in grams. So I know that 1 kilogram is 1,000 grams. So therefore, to turn kilograms to grams, I must multiply by 1,000. So if I have 12.5 kilograms, I'm going to need to multiply that by 1,000, and that's going to give me 12,500 grams. So now that my mass and my density are in the same units, I can substitute that into the formula. So I know that volume is mass, 12,500, over density, which is 19.3. So I type that into my calculator, 12,500 divided by 19.3, and I end up with a volume of 647.6683938, and it said round to 3 significant figures. So when I'm rounding to significant figures, I literally I go to the third digit that has place value. So that's the first significant figure, second, third, and this is what I'm rounding. So I'm rounding to the nearest unit. So I look next door, it's more than 5, so I'm going to round that to 648 to 3 significant figures. Next, I've got a ratio question. So I'm told that there are only blue pens, green pens and red pens in a box, and that the ratio of the number of blue pens, so blue pens to green pens, is 2 to 5, and that the ratio of the number of green pens to the number of red pens is 4 to 1. So what I do is I've been given 3 types of pens, but I've been given 2 separate ratios, and I'm going to somehow try and combine them. So I'm told that there are less than 100 pens in the box, and what is the greatest number of red pens in the box? So to do this, I'm going to need to use my equivalent ratios. So I can see that I have my green is in common. So I want to find the lowest common multiple of 5 and 4, which is 20. Because if I have my green in the same ratio, then I can get equivalent ratios for everything else. So if I multiply this by 4, that would get me 20. So 2 times 4 is 8, 5 times 4 is 20. And what would I have multiplied 4 by to get to 20? I would have multiplied it by 5. So I multiply 1 times 5 as well. So now, because effectively what I've done is I've said blue to green is 2 to 20, and green to red is 20 to 5, because I have a common thing, I can combine all of them. So I can combine blue to green to red, I know is in the ratio of 8 to 20 to 5. So what's the greatest possible number of red pens in the box? Well, in total, I know that I've got 20 plus 8 plus 5 pens each time I'm sharing them out. So 20 plus 8 plus 5 gives me 33. And how many times can 33 fit into 100? If I did 100 divided by 33, that would give me 3.03. So I know that 3 full sets of this ratio partition are going to fit into 100. So the number of red pens is 5. So I know I can times that by 3, times everything by 3, and I'd end up with 15 red pens would be the maximum amount of red pens. Because if I did this ratio, say I split it, another way that you could have done it is just thought to yourself, okay, so if the ratio is for every 8 blue pens, there are 20 green pens and 5 red pens, double it. So the next time you split it, you know, it would be 16 to 40 to 10, add on another set of the ratio, that would be 24 to 60 to 15. So you're just, each time you split in ratio, you need to make sure that you're dividing by all of the parts. Okay, next I need to find the value of the reciprocal of 1.6. So all the reciprocal means is if you turn your thing into a fraction, to turn any number into a fraction, you just write it over 1. And the reciprocal is if you just flip the numerator and the denominator. So the reciprocal of 1.6 would be 1 over 1.6. Now, because it's a calculator paper, I could just type this into my calculator either as a fraction, or I know that this line means divide. So I could write 1 divided by 1.6, and that gives me 5/8. So I press format and decimal. So that gives me 5/8, which is 0.625. So a reciprocal is just the number flipped. If it's a fraction, so let's say it was 3 over 8, the reciprocal would be 8 over 3. If it's a whole number, you write it over 1 and then flip it. Okay, now I'm told that Jess rounds a number, x, to 1 decimal place, and the result is 9.8. And I need to write down the error interval. So what I want to do is think to myself, okay, so 9.8 has been rounded. And if it's been rounded, what are the decimal places it could have either rounded up or down to? So it could have rounded down, my number could have rounded down to 9.7, or it could have rounded up to 9.9 because I'm dealing with one decimal place. So I'm just looking at the decimal point. So what is the minimum number that it could be before it would have rounded down to 9.7? So 9.75 is the midway point, and 9.85 is the midway point between my two decimals. And if it was 9.74, for example, so 9.74, it would round down to 9.7. So 9.75 is the lowest value it could be in order to round up to 9.8. And similarly, the highest technical value it could be would be 9.8499 going on until infinity. But because I'm doing an error interval, I can just say that 9.75 has to be less than or equal to x, because it could be 9.75, that would still round to 9.8, but it has to be less than 9.85. So instead of writing 9.84999, I just say it can be anything up to 9.85. So an error interval is where you think, okay, what numbers could it possibly have been? It's in between these two values, could be anything in between them, and that's how I'd write my error interval. You always write it as less than or equal to the minimum number, and then less than the maximum. So here I've got a rectangle, and I'm told that the length of the rectangle is 7 centimeters longer than the width. So I've got my width, and then I've got my length, and I know that the length is 7 centimeters longer. So whatever the width is, I add 7, and that's going to give me the length. So I can write that down. I'm told that 4 of these rectangles are used to make this 8-sided shape, and that the perimeter of the shape is 70 centimeters. I then need to work out the area. So first of all, if I've labelled this triangle, I know that the length is w plus 7. So anywhere I see a length, I could write w plus 7. So w plus 7 here, w plus 7 here, w plus 7 here. And then anytime I see just the width, like here, I've got w, 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 and then, and w over here as well. And then I'm left with these little bits for the perimeter, because remember the perimeter is the distance around the outside, so I only want the outside of the shape. So how could I figure out what this length here is? So I know that this over here is w plus 7, and I know that this length here must be w because it's the width. So that must mean if this is w plus 7 and this part here is w, the remainder must be 7. So I'll just label that as 7, and the same would be over here, because if this is w, w plus 7 is over there. So I only need the outside bit for the perimeter. So let's add everything together, because perimeter, when I'm working out the length of the outside of the shape, I want to add all the values of the sides together. So I've got w plus, or it might be quicker to just actually, no, let's write it out. So I've got w plus w plus 7 plus w plus 7 plus w plus 7 plus w plus w plus 7 plus w plus 7 plus w plus 7. So then I just want to simplify that, bring all of my letters together. So I've got 1, 2, 3, 4, 5, 6, 7, 8 lots of w, and I've got 1, 2, 3, 4, 5, 6 lots of 7. 6 times 7 is 42. So 8w plus 42 is my perimeter. So I've worked that out. And then once I've worked out that my perimeter is 8w plus 7, I can make it equal to what they've told me the perimeter is. So I know that 8w plus 42, sorry, 8w plus 42 is equal to the perimeter. And they've told me over here what the perimeter is equal. It's equal to 70 centimetres. So 8w plus 42 must be equal to 70. Now this is just an equation that I've formed. I've managed to form an equation. So I can then solve it. So I subtract 42 from both sides and I'm left with 8w equals 70 take away 42 is 28. And then I can divide both sides by 8. So w is 28 divided by 8 is 3.5. So I've worked out that w is 3.5, and now I need to work out the area of the shape. So in order to work out the area of the shape, how do you work out area? Area is just length times by width. So I now know that w is 3.5, the width is 3.5, and w plus 7 is going to be 3.5 plus 7, which gives me 10.5. So to work out the area of these rectangles, I'm going to do 3.5 times by 10.5. And that would give me an area of 36.75. So the area of each of these is 36.75. Now with area, you're just literally working out the space that takes up inside the shape. So I know that that is going to be one lot of 37.5. That is going to be another lot. That is going to be another lot. And that is going to be another lot. Because I'm told that the 4 rectangles are equal. You're using the same rectangle. So all I'm going to do, once I've worked out the area of one, I have to multiply it by 4 because there's 4 lots of them. So I do 36.75 times by 4. And that would give me 147. So 147 centimetres squared. So this is quite a tricky question. It involves lots of things, but use the information that's been given to you, use what you know about perimeter, and try and take it one step at a time. Okay, next I've got a standard form question. So remember, you are allowed to use your calculator for this, so that makes it a lot easier. So I can just write this out like this and ignore the brackets for now, because everything is being multiplied. So what I want to do is multiply these two numbers. So 13.8 times by 5.4 gives me 74.52. And then I can use the laws of indices for this. So when I'm multiplying indices, so 10 to the power of a times 10 to the power of b, that would become 10 to the power of a plus b. So in this case, 10 to the power of 7 times 10 to the power of negative 12. When I'm multiplying, I add the powers. So that would become 7 plus negative 12. And when you've got a plus and a negative next to each other, that just overwrites it as a negative, because when you're adding a negative number, it's the same as subtracting. So 7 take away 12 would give me negative 5. So that would be 10 to the power of negative 5. Now I need to give my answer as an ordinary number. So 72 times by 10 to the power of negative 5. If I type that into my calculator, it tells, well, it simplifies it to standard form, so that's not going to help you. So it tells you that it's 7.2. Oh, I wrote 72, I don't know why. So it's 7.452 times 10 to the power of negative 4. Now, when you're doing something to the power of negative 4, all that means is you want to move everything so that it's 4 places to the right. So if it's written in standard form, that's what we do. Just to quickly recap, if you're not super familiar with standard form, let's say I've got 10 cubed, that's 1,000. 10 squared is 100. 10 to the power of 1 is 10. 10 to the power of 0 is 1. 10 to the power of minus 1, following this pattern, each time I'm dividing by 10. So that would be 0.1. 10 to the power of minus 2 would be 0.01. To the minus 3 would be 0.001. And to the minus 4 would be 0.0001. So essentially, I'm multiplying 7.452 by 0.0001. When I'm multiplying decimals, you can literally multiply, you can turn everything into whole numbers. So that's the same as saying 7,452 times by 1. And then what your answer needs to have is however many decimal points, however many digits are after the decimal point in your calculation. So you've got 1, 2, 3, 4, 5, 6, 7 digits after the decimal point. So you know your number is going to have 1, 2, 3, 4, 5, 6, 7 digits after the decimal point. So you can start filling it out from the back. And then you add in the zeros for anywhere in front of it. So that's one way, or the other way is, you know it's to the power of -4. So you start writing your decimal after the 4th zero. So 1, 2, 3, 4 zeros, and then you start writing your number. So that's the two ways that we can do this. And an ordinary number, that just means like either a full decimal or a full whole number, no times 10 to the power of something. Okay, so here I've got a probability question. I'm told that when a drawing pin is dropped, it can land point down or point up, and that Lucy, Mel and Tom each dropped the drawing pin a number of times. The table shows the number of times the drawing pin landed point down and the number of times the drawing pin landed point up for each person. And then I'm told that Rachel is going to drop the drawing pin once. And the question asks me whose result will give the best estimate for the probability that the drawing pin will land point up. Now, the greater the number of throws, the better the estimate will be. So this applies to anything. The more times you try something, the closer you get to working out the actual probability of it happening. Like if you opened up a pack of, I don't know, Smarties or some kind of sweet, and you counted how many blue Smarties there were in it, but that was just one pack and it happened to be a pack that had a lot of blue Smarties, you'd think there's a really high probability of getting the blue Smarties. But if you opened up 200 packs, over those 200 packs, it would average out. So the more times that you try something out, the better the estimate for the probability that it is. So that's just a fact that would be really handy to know. So therefore, the greater the number of throws, the better the estimate will be. So who threw the most amount of times? So Lucy threw 31 plus 14. So she threw the pin 45 times. Mel threw it 53 plus 27. So that's 80 times. And Tom threw it 25 times. So therefore, Mel's results will give the best estimate. Okay, now for the second part of the question, I'm told that Stuart is going to drop the drawing pin twice, and that I need to use all the results in the table to work out an estimate for the probability that the drawing pin will land up, point up the first time and point down the second time. So I've got all of these results, and I want to use them all to work out the total probability. So the total amount of times that it is landed point down, the total amount of times that it's landed point up, and the total amount of times it's been thrown. So if I do 31 plus 53 plus 16, that gives me a total of 100. Then 14 plus 27 plus 9 gives me a total of 50. And 45 plus 80 plus 25 gives me a total of 150. So in total, it's been thrown 150 times, and the probability that it would land point down is 100 out of 150, and the probability that it would land point up would be 50 over 150. So using that, I can go down here, and the probability that will land point up first time is 50 over 150. You could simplify this, but you don't need to. And the probability that it would land point down the second time is 100 over 150. Now, using probability, whenever we're told that we want to work out the probability of this and this happening, it's the and rule, and we multiply the probabilities to find out what the answer is. So 50 over 150 times 100 over 150, you can just type that into your calculator as fractions, and that would automatically, if you write it, it automatically simplifies it for you to 2 over 9. So the key thing is work out the probabilities. You work out the probabilities by always having your denominator is the total, and the thing that you're doing is your numerator. And then if you're working out the probability of this and that happening, you multiply the two probabilities together. Okay, so now I'm told to solve the simultaneous equations. So the key thing with simultaneous equations is the first thing you want, this is quite a tricky one, you want to have either your x or your y variables to be the same. So none of these are the same. This is the trickiest kind of simultaneous equation. So you first just decide, do I want to make my y values the same or my x values? I'm gonna go and make my x values the same. So in order to do that, this is x currently, I'm going to need to times it by 5, and then it will become 5x. But because I'm doing that, I need to do the same to each part of the equation. So this is going to become 5x plus, 3 times 5 is 15y, and 12 times 5 is 60. You can use a calculator to do this. And then I rewrite the other equation underneath. So I've got 5x minus y equals 4. Now that I've got one of the variables, in this case the x variables, that are the same, I can subtract, I can eliminate it. So in order to eliminate it, I need to think, do I add or do I subtract? 5 plus 5 makes 10, so if I add, that's not going to eliminate. So I know that I'm going to have to subtract. And it's good to write out what you're doing just next to the equation there, so that you know that you do it to each part of the equation. So you've got 5x take away 5x, that cancels out to 0. Then you've got 15 take away negative y, and this is where it's really important to be good with your negatives. So when you've got two negatives next to each other in between your numbers, it becomes a positive. If you just think about it, if you're taking away a negative, essentially you're adding. So if you think about having like I don't know, ice cubes in soup, and you take out the ice cubes, the effect is that you're going to make it warmer because you're taking out the cold, you're taking out the negative. So subtracting a negative is the same as adding. So 15y, that was meant to say 15y minus 1y. So 15y take away negative y is the same as saying 15y plus y, which would give me 16y. And then 60 take away 4 is 56. So now I've just got an equation, and to figure out what y is, I'm going to have to divide by 16. So 56 divided by 16 is 3.5. So I know that my value of y is 3.5. Now, when I figured out one of my values, what I can then do is substitute back into the easiest equation to figure out what my x value must be. So it doesn't really matter which one you pick. We're just going to say y equals 3.5. And then let's have a go at substituting back into it. So when y equals 3.5, I'm going to just choose this one. 5x, take away one lot of y, which would be 3.5, equals 4. And now I need to solve this equation to find out what x is. So I add 3.5 to both sides of the equation, and I'm left with 5x equals 7.5. I then have to solve it, so I'm going to divide by 5, and then x is going to be 7.5 divided by 5, which gives me 1.5. So to solve the simultaneous equations, you need two things. You need to have told what the x value is and what the y value is. So you just say x is 1.5 and y is 3.5. And that's the end of this exam. So if you found it helpful, or if you want a bit more explanation on any of the questions, this was quite a difficult exam, just let me know and I can make a separate video for individual topics. But other than that, good luck with all your revision.